Okay, so we have a very simple circuit here. We've got a 15-volt power supply cruising around. Let me up that just a little bit. It's getting hot. See if I can get exactly 2 amps. I don't know if I can. Nope, I can't. So we're going to be running this at 1.9 amps. And so we see that it comes, the plus terminal here goes around this triangular coil of wire. This is a 200 turn coil of wire. And then it comes out, and then it goes back to home. And this device is actually a magnetic field sensor. And so notice that we're only getting 2 sig figs here, and you'll notice as we take the data, the data is going to have significant errors, so we're going to be lucky to get 2 sig figs. So if you see me use some measurement techniques that you're thinking, oh, shouldn't he do a better job at that? You're right, but since I know we're only getting maybe 1.5 to 2 sig figs most of the time, I'm not going to try to be perfect, and I just want to get this over with. So this is will give us a good order of magnitude estimate for the magnetic field created by this triangular coil of wire. Now some dimensions of this thing before we get too far along. So hopefully you can see this. Let's just get the height of this thing. So now you got to be a little bit tricky because there's the inner part of the coil and the outer part of the coil. By the way, this black stuff is plastic, so it's non-conducting. So I argue I'm going to raise up the meter stick about halfway through that coil, and maybe you can see, for me, I thought the coil, and then you want to go to this middle part of the coil here, not the outside, not the inside, somewhere in the middle. So you're trying to go middle to middle. Well, this is getting warm. That gives you an idea of about how tall this is, somewhere slightly under 20 centimeters. Also, you can see that right here, go from this side, so you can see the height of this. Whoops. The height of this sensor is about maybe a little over 6 centimeters. Again, you shouldn't use that first centimeter because it's been beat up by students, but again, we don't care that much about the sig figs, so hopefully you see this is about 6.5 centimeters up off the ground. And this is where the sensor is detecting the magnetic field, where these dots are. Now if we could get a top view of this, hopefully that looks like you could see that this is right in the middle of the triangle. So this is hopefully on the main axis of the triangle. It's not perfect, but again, who cares? It's getting an order of magnitude. Alright, so I'm going to go ahead and leave that here. Okay, so now let's go ahead and I'll show you some data here. So this sensor actually is set to read the magnetic field that's entering this face. Alright, and so what I'm going to do is I'm going to set it here. I'm going to disconnect the power supply for a minute. Make sure it's reading 0, I'll tear it out. Alright, and so now I know that any external magnetic field from the Earth or anything else should be approximately zeroed out, at least during the central region there. Now I'm going to go ahead, plug this back in, and we can take data for every 2 centimeters or so. So what I'm going to do is start over here, let's say how about 16 centimeters away? And I'm doing my best to line up this sensor. There's 2 marks here that I'm trying to line up so that it's approximately 16 centimeters from the center of here. I'm just going to adjust it a little bit because I bumped it a little bit. Okay, that's good. Okay, so now you can get this reading, and you can get there. See what I mean about only 1 sig fig? So that was 16 centimeters away, 14, 12, 10, 8, 6, 4, 2, right at the center of the coil. Then we'll go the other way a little bit. That's 2, whoops, there's about 2, 4, 6, 8, 10, 12, 14. And finally, let's get out here. Cable's pulling a little bit. There we go. I'd say that's 16. Okay.